Okay, maybe I'll start. So, like in the last class by Professor Pulok Mishra, we all discussed about time series, right? Uh, so today also we will continue our discussion on time series, but since this is the second module of this course, which is about learning from data, we will actually try to bring in a learning aspect to the problem of time series. So first of all, let us talk about so how AI and ML can help in problems related to time series. So, since this module is related to learning from data, obviously we are going to use techniques related to machine learning because that is the way. Because what is machine learning? Machine learning provides us with a set of algorithms which enables us to learn from data. Now, learn what? That we will come to like in a bit. So, I guess many of you have taken some course on machine learning. So, can any of you unmute yourself and tell, in case of machine learning or in case of any machine learning problem, what is it that we learn from data? Anyone would like to answer? What do we learn? What is the learning about?
Patterns we identify.
The trend.
The trend. Okay, trend is like it's like very specific to time series. Patterns again also is like correct, but it's a very general term. Can anyone explain a bit more specifically what exactly we learn from data?
So the parameters of the model.
Okay. Basically, in case of machine learning or in case of any machine learning algorithm, what we do is we build a model. Model for what? Model for the data. Model for data. Now, this model has will have various kinds of parameters, maybe one or maybe more parameters. So, there are many design choices we make here. First of all, which model or what kind of model, and whatever the kind of model is, it will involve certain parameters. So, what will be the values of those parameters? So, these are all questions what we need to answer with the help of data. So, in case of any machine learning problem, what we have is data initially. So using that data, what we do is we build a model, and this model includes what? Includes it may include some mathematical functions, and it may also include the various parameters. So just to give a quick example of what I mean by that. So suppose the data which I am dealing with is time series data. Now, what is meant by time series data? That means I have a sequence of observations where each sequence is like marked with a timestamp. So let me see that. Let's say that the time has been divided into points like this: T1, T2, T3, like all the way up to maybe Tn minus one, Tn, Tn plus one, etc. And at so these are time points, and at each time point I have certain observations. Now these observations which I am making, they may be numeric, that is, or they may be non-numeric. So we will see examples of both. So examples of numeric time series may or examples of numeric data may mean like they may be either some scalars or let us say maybe say real numbers, or they may be vector. That is, instead of a single observation at any time point, there may be several observations, each of which are number that are represented as a as in the form of a vector. So, like if we can talk about the context of economics, so the like a simple example or a very common example of numeric time series maybe the GDP growth rate, or simply the maybe the GDP of any given country, let's say India. Now, so we can maybe the GDP the GDP growth rate, or maybe the GDP itself may look like this. That is, at different time points, I may plot its value, and it may look somewhat like this. Something like this. Okay, so this is a sample time. Like this is an example of a numeric time series. Now, it may also happen that instead of focusing on a single quantity such as the GDP of the whole country, you may actually want to focus on various other attributes also. Say, like for example, what about the GDPs of the different states individually? So that is to say, we may not be interested in the GDP of the whole country as a as a single entity, but I want a more nuanced representation about each of the different regions. So that way, in that case, we may get something like a vector, right? So for like a very simple model for time series, I think Professor Mishra may have discussed this in Friday's class. It may be something like this. So let us say that for the time being, let us say that we are focusing only on real numbers. Okay, that is a time series where each element is a real number. So I can say that at any given time, the observation or the value is a real number. And now the idea is that I want to express the value of whatever I am measuring, of whatever variable I am measuring at time t, as a function of maybe some other things. So what can these other things be? Any idea based on the previous day's class? xt is a can be expressed in terms of what? Can we write xt in terms of different components? What are the different components? Anyone wants to answer? Pooja Arak, can you tell me what are how can I decompose xt into different components?
Like, I don't know exactly.
In the last class, was anything discussed about say trends, cycles? Okay, fine. Leave it. So let us say that in any kind of time series model, let us say that there is a long-term trend. So we can write xt as like trend. This is like a it's a long-term thing. It may not be changing very rapidly. So here you can see that there are lots of ups and downs in the time series, like if you look at any particular time series, there is a very slow moving component to it, which is free from all these fluctuations. So that is sometimes called as the trend. Apart from that, there is a cyclical or a seasonal component. So then, so what is a seasonal component? So it's something like this. So it may look somewhat like this, an oscillatory component. So, like if we are considering, say, the GDP, there may be an overall trend that over the years the GDP will keep on increasing. Right? It is not going to decrease, but like albeit at a slow pace, but it will keep on increasing. So that is the trend component. Now, within again, but on top of that trend, there can be certain fluctuations, and these fluctuations again may be like as a function of time. So this is known as the cyclical component. So it may happen that that a particular country, or like there may be a particular country where like in certain quarters the GDP growth rate, the GDP growth rate is high, and in some other quarters it is low. Now, why that should happen is a different matter, or whether that can happen is a different question. I'm just giving an example. So suppose there are like there is a regular oscillation like this. Instead of GDP, if we say suppose the say the sales of a particular item. So like if we suppose we are talking about the sales of winter wear. So we can, that is easy to understand that like in winter month, the corresponding value, the sales value of the item will be high. In summer, it will be low. So again, next year in the winter, it will be high. Next summer, it will again be low. So that is a seasonal or the cyclical component. So at like at any given time t, whatever the value we are observing, it may like it will be a function of the trend. It may be a function of the cyclical component, or then it may be like it may also be there may also be a random component which okay, let I'll come to that a bit later. Let me consider that there are also certain other covariates which I denote by Y. Okay, so there may like apart from this particular economic this particular variable XP, there may be some other economic variables or maybe other non-economic variables also which I express as YT, and it may happen that these I call these as covariates. So it may happen that these are like the influence XP in some way or the other. So like we can actually express this as some kind of a transformation. So that is YT may be like one single variable or a set of variables, whatever. It may be a vector of variables also. But like we use these to but these YT, these observations impact the value of XT through this kind of a transformation A. So this again, like what this A is, well, like it may be a matrix or it may be a scalar, depending on what XT and YT are. So for example, if XT is a scalar and YT is another scalar, so then obviously A will also be a scalar. So, but it's like saying that the like in that simple case where like all of these are scalars, I can write this, which is basically meaning saying that the say this particular variable can be expressed as some constant times the value of some of the other variables. Let us say that so if XT is say the sales of winter wear at any given time t, and YT may be some let us say it's the total GDP. Okay, so like we know that like if at or maybe the if YT may be some variable that in some way it encodes the purchasing power of people. So we know that if people have more purchasing power, then the sales of that item will be high. If the purchasing power of the people drops, then the sales will also go down. Right? So there may be a scaling factor which may express this kind of a relation. I am not saying that this is a very good way of representing, but as of now we are just telling some very very naive things. So let us say like this. And then, so there is a like there is a trend or the long-term component. there is a cyclical or a seasonal component, there is the effect of the covariate, and then finally there may be a random component, which is which basically takes is effect of factors which cannot be measured by any of these things. So ideally the random component may be part of the covariate, but then we may not know all the covariates. We cannot go on counting the different factors which impact this particular variable. So whatever factors we are not able to enumerate or we are not able to represent mathematically like this, we just assume that they are part of a random component, which in a sense are about the unknown factors. So instead of writing these xt plus xt cycles, that is, instead of saying that these are just added up, I may also want to just like this has been pre-multiplied by this transformation coefficient A, I may want to pre-multiply them with some other coefficients. So this is we can say it's a very simple model of a time series, but this has parameters. So what are the parameters of this time series?
Hello, sir.
Yes. What are
Sir,
the
your voice is cracking a lot. So
okay. Sorry.
Is this now better?
yes, sir.
Okay, so now tell me, so suppose this is the model which I am proposing for this particular economic variable xt. So what are the parameters of this model? Quick.
So A, B, C.
A, B and C in this case. Additionally, this random component epsilon which I have considered, it's a bad epsilon, this additional random component which I have considered, this may also have its certain parameters, so let us consider those as theta. So these are the different parameters of the model. So now so as I said earlier, in the task of machine learning will be to, or one of the tasks of machine learning is to estimate these parameters with the help of data. So in what way will I go about doing it? So the first step is to define a loss function. So what does the loss function do? The loss function basically, let me denote it in this way, L. So the loss function is basically, it compares the predicted value of the time series at any given point against its actual value. So let us say that xt is the observation, and the prediction which our model makes is, let me denote it by xt hat. xt hat. So basically what the loss function does is, in some way it compares the true value against the predicted value, and then what the aim of our any algorithm is to choose the parameters in such a way that the loss function is minimized. Now the loss function is such a function that takes low values if the if xt and that is the predicted value xt hat and the true value xt are nearly equal to each other. If they are close enough to each other, then it takes a low value, and if they are far from each other, then they take high value. Okay. So they basically, it is in my so since I want my predicted values to match the true values, so what I want is, I want the loss function to have a low value, and this is not on the basis of only a single time t, it should be like I should calculate the loss functions at like over a period of time, which consists of which may consist of many time points, and I'll add them up, and it is this total loss function which I want to be as low as possible. So now our aim then is something like choose A, B, C such that this loss function is minimized. So basically this can be done by some kind of an optimization algorithm. So this is all that you do in the learning part of the of your algorithm. That is whenever you are deploying a machine learning algorithm. So what does it do? It first every machine learning algorithm is associated with a model. That is this is one particular model which may be the property of one particular algorithm. If you are considering another machine learning algorithm, it may build a different model for the data. Okay. So the first of all, your model, like whatever machine learning algorithm you are choosing, it will specify a model. Now that model will have parameters. The aim is to choose the parameters or choose the optimal values of the parameters. What do I mean by optimal values? So for that, whatever algorithm you are using, whatever machine learning algorithm you are using, will also give you a loss function L, and the parameters will have to be chosen such that this loss function is minimized. It is as low as possible. Okay. So on this, how will I measure this loss function? I will measure it with the help of data. So at every data point, I will have a true value as well as a predicted value. Now, from where am I predicting the value? With the help of the model. The model is basically it's a model for what? It's a model for the data. So the model basically allows me to predict the data. So so like here is a predicted value which I denote as xt hat, which I have obtained from my model, and there is an xt which is the true value or the observed value, and then I calculate the loss function and the loss function's property is such that it will be low if my prediction is close to the true value, and it will be high if they are different. And then I choose A, B, C and or the various parameters of the model in such a way that this loss function is minimized. Okay. And once I have got the optimal values of these parameters, then I can go on making predictions. So for future predictions, I will be using those estimated values of the parameters which I have obtained from my optimization algo. So if those values are say A hat, B hat and C hat in this case, I will use these values to make the further predictions. Okay. So this is basically in a nutshell, this is how we can use machine learning for this or machine learning algorithms for this class of problems. Okay. So in this class, I will be frequently making sketches like this, and all these sketches will be shared with you also in the Teams folder. So there will be a separate folder called sketches where I will upload all of this. Now, so why do we want machine learning for time series problems? So what are some of the typical time series problems which machine learning may help to solve? So here I am going to give you a few like a set of generic problems. Now what you will have to do is you will have to tell me some economic problem in which that particular class of algorithms is or that particular machine learning problem is useful. Okay. So for the first of all is the very basic problem related to time series, that is time series of forecasting. So what is time series forecasting? Anyone wants to hazard a guess? This should be quite self-evident. Anyone wants to hazard a guess about what is time series forecasting? Quick, please respond quickly. Quick, what is time series forecasting?
To estimate the future values given the past data.
Exactly. So given the, like, suppose this is my observed time series so far. Now based on these, can I, so let's say these many values I have observed till maybe t equal to 10, let us say. Now then, based on these, based on all these, now can I predict the what is the going to be the observation at t equal to 11, or how about t equal to 12 or t equal to 13? Can I predict these values? So obviously that is the forecasting problem. That is you have to predict xt given x1, x2 all the way up to xt minus 1. Along with it, you may also have access to various covariates, say y1, y2 all the way up to yt minus 1 and even yt. So what are these covariates? Again, I already mentioned these are maybe some other variables which you already know has a direct impact on this particular variable xt that you are trying to measure. Okay, so this is the this is the forecasting problem. Now can you tell me an economic problem which is essentially a forecasting problem?
Stock price forecasting.
Stock price forecasting. So suppose that you are interested in the stock price of a particular company and you have observed its past few like its past values and you also know like whatever covariates may influence the stock price of that company. So based on that, based on your observation so far, you want to predict the next value. Okay? Fair enough, simple enough. Next problem is that of classification. Time series classification. Okay, before I go into the time series classification, let me ask a like a very simple question. What for especially for those who have already attended machine learning, what do you mean by classification? What is a classification problem?
For identifying the class labels of different points.
So can you give an example of a typical classification problem?
So one of them is spam detection or credit card fraud detection. If I'm giving the labels.
Okay, spam detection. So what's the spam detection problem? The spam detection problem is like basically you have got lots of emails and every email you know is either spam or useful. So like you need so there are two possible labels for every email. Either it's a spam or it's useful, which some people may say ham also. So every email has to be classified into one of two possible classes, either a spam or a ham. Now, so in that case, the input, what is the input to the classification algorithm? The input to the classification algorithm is the email itself. So how you represent the email? So email is, as we know, is a it contains words, numbers, sentences, paragraphs, etc. So how you exactly represent the email when you present it as an input to the algorithm is will depend on the nature of the algorithm itself. We are not going into all that. But in case of a time series classification problem, the input is a time series and the output is a label, which may be a binary label or it may be some other discrete label also. So for example, let us consider a time series classification problem. So let us say that there are different time series like this. So so like a simple time series classification problem, I am calling it as cyclical versus non-cyclical. So given any time series, you will have to predict whether, or you have to classify it as is this a cyclical time series or it's a not cyclical time series? So this may be your one example. And obviously this is a cyclical time series. Next, consider another example. So this time series will be the input to your model. So again, how your model will take this kind of a time series as its input is like that will depend on the specifications of the algorithm which you are considering. But like let's just keep it at that. So this is one. So this we can say this is a second time series, which we call it as a non-cyclical time series. Third one, this is again a cyclical time series. Fourth one, it just goes on increasing. This is also a non-cyclical time series. So like basically you will get various time series like this, each of which has to be classified into like according to two or more categories. In this particular problem, the categories are cyclical and non-cyclical. It may also be some other category. Like for example, here is another example of a time series. So these are also sample time series, and like so each of these time series may have a label associated with them. Now the classification problem is that given a new time series, you will have to predict which label it should have. So like let us consider the first case of cyclical versus non-cyclical classification. So let us say that you have been given a set of time series like this, which are labeled. That is, you have the time series and a corresponding label. Now you are given a test time series, which maybe it looks like this. Something like this. And now you'll have to predict whether its class level is cyclic or non-cyclic. So whatever your algorithm is, or whatever the machine learning model which you have used, it will basically it should have estimated its various parameters, etc., from these label data, and accordingly when you provide these this new time series, it will be able to predict for you whether this is a cyclical time series or a non-cyclical time series. Okay, now can you tell me an economic problem where you have to classify time series like this? I mean, not necessarily cyclical versus non-cyclical, but some other classification will also be fine. Any economic problem? Anyone wants to hazard a guess? Anyone? Utkarsh?
Classifying goods according to the tax slabs.
Classifying goods according to tax slabs.
Like which tax slab it belongs to, like in the GST.
I see. Okay, maybe possible. Oh, okay, fine. Anything else?
So checking if the stock market goes up every year after the budget is announced.
Okay, possible. Another possibility which I was considering was what about these credit ratings? So you know that there are certain rating agencies like say Standard and Poor and so on. What these agencies do is that they they provide certain ratings to different firms or to different agencies, or even to different countries, like we often hear that we often see in the news that Standard and Poor has improved India's rating, or it has reduced India's rating and things like that, right? So what basically that means is that it is trying to what these ratings are, it's basically it's like it's giving the investors some kind of an advice or some kind of an estimate of whether this particular company is, or this particular economy is worth investing in. If you invest in this company, can you expect to have to have good returns later? Right, so that's the whole idea of credit ratings. Now, of course, predicting how much your returns are going to be at a given time and so on is difficult, but you can at least give them an expectation, like you can give them some estimate, maybe some discrete choices, like you can expect high returns, or you can expect medium returns, or you can expect low returns, something like that. So if we give discrete levels like this, then it might be easier for a person to comprehend that that whether I should invest here or not. So that's so here there are only a small number of or a limited number of labels being considered. So so what is the basis of these ratings? So the basis of these ratings will obviously be the past performance of that agency or that or that economy, whatever. It may not be on the basis of a single variable as I have plotted here. It may be on the basis of multiple variables. That is, we may have a multivariate time series also like this. But whatever it is, it becomes something like a time series classification problem. Each time series is to be classified as whether that is based on the past time series of that agency or that country or whatever. You have to predict whether if you invest there, will your expected returns, are they going to be high or medium or low or something like that. So that's an example of a time series classification problem. Next, I am talking about the next problem, which is time series clustering. So times, what is the difference between classification and clustering? Those who know ML.
Sir, I don't in clustering I don't have the ground truth labels for the data.
Right. So in case of classification, like there is a training phase where you are provided with the input along with the corresponding output of the labels. So for example, in this problem, you are given a time series like this. You are also provided with its corresponding label, that is either cyclic or non-cyclic. But if you consider this problem, you are given only time series, but you are not given any labels. So now, what do you have? So now what do you have to do with this time series? You will somehow have to group those time series which in some way appear similar to you. Now, what is similar in what way, that may again that may vary from one algorithm to another. But the idea of clustering is that you will have to, that you are provided with a large number of examples, and you will have to identify which of them are in some way similar to each other. So if that is time series, so you are provided with different time series, and you will have to identify which time series may be together. So based on the examples which I have drawn here, can you suggest like which time series should be clustered together? Quick.
Sir, can you repeat?
These time series I have provided to you, these four. So suppose now I want to cluster them together. That is to say, those time series which are similar in some way, they have to be taken together. So can you suggest which time series out of these four, which time series are similar to each other?
Sir, first and fourth, and second and third. You
mean to say the first and fourth are similar to each other, second and third are similar to each other, right? Yes, so why do you think first and fourth are similar to each other?
Sir, because they are uptrending and the other two are downtrending.
Right. So even though they are maybe the individual values of the time series may be different, or even though the nature of their oscillations may be different, but the first and the fourth, in both cases, they have a general upward trend. So if we extract the trend component of the time series, in both cases, we will have a positive trend. That is, over time, it keeps on increasing. I mean, there may be fluctuations from like from this point to this point, there is a decrease. But if you consider if you get rid of those fluctuations and if you look at only the trend, the long-term component, you will see an increase. But in this case, similarly, you will see a decrease. So here we can say that the A and B should belong or say the first and fourth should belong to the first cluster, which I am calling A, and the second and third should go to the second cluster, which I am calling as B. Okay, so that is the time series clustering problem. Now suggest to me an economic problem which is related to time series clustering. Quick.
Sir, on the basis of stock price data of different companies, we can cluster those companies together, showing the same patterns.
Exactly. Yes, that's a very good example. So we have got the stock prices of different companies. Now, some of them may be their stock prices may be improving over time. Some of them may be that is reducing over time. Again, those which are improving, some of them may be improving fast, some of them may be improving slow, etc. So we may want to categorize companies like that. We may want to cluster companies like this. So, for example, if I am the government which wants to boost some of those companies which are sick, whose stock values are not improving fast enough, or which are actually going down. So, in that case, I would like to first get an understanding of the situation of which all companies are sick like that. Similarly, I will also want to understand which all companies are healthy like that, and so that I can give different interventions to the different groups of companies. So for this purpose, I may want to do this time series clustering. Right. So these are some of the problems related to time series, which translate directly to machine learning problems. Now, another problem which I would also like to mention here is the problem of change point detection. So suppose you have a time series like this. Just give me a second. So as you can see, if you look at this time series, it's obvious to the eyes that this time series has different regimes. Say till this point, let's call it at T1, it was behaving in one particular way. Soon beyond this point T1, it is shooting up rapidly. It reached a high value, and it remained quite high for a long time up till say point T2. After which it suddenly fell abruptly to a quite low value, and then since then it is like showing a general upward trend with a lot of fluctuations. So there is a slow upward trend. So here we see it's a cyclical with a constant trend. Then there is a huge increase or an abrupt increase, and then again it becomes slightly cyclical or nearly constant at a higher value. Then there is an abrupt decrease, and then it becomes a slow moving or a slowly increasing trend, and this goes on. So the problem here is to, given a time series, I may want to decompose it in the time series into these kinds of regimes like this. So I may not know how many regimes are there. I may not also know exactly at which points those regime changes occur. So here this problem is sometimes known as the segmentation problem. The segmentation of a time series into regimes, where I do not know how many regimes, nor do I know when the regime change points, or which are the regime change points, right? So now tell me an economic problem where this is relevant. Can you please tell me up
different waves of the coronavirus, like the first wave, second wave, third wave?
Yeah, interesting. Yeah, so that's a good idea. That's a good example. So like now we are actually not talking exactly of coronavirus, but we are talking about economy. But we may know, or we may be interested in asking that if we consider the whole period since say March 2020, if we consider India's GDP growth rate, and if we want to identify that which are the points or the change points of that time series, that will basically enable us to identify at which points there has been a significant change in the behavior of the GDP growth rate. Like for example, the announcement of the first lockdown may have had a significantly or may have brought about one change point in the GDP. Then maybe announcement of some stimulus package may have slightly perked up the GDP for a short while, but maybe it did not make any significant difference. So we see that GDP again dropped off after a while. Then maybe the lockdown may have been lifted, or all curbs may have been lifted, and after that we may have seen a gradual upward trend. And then maybe at another point again a second wave started, and so another lockdown was declared. So again we saw the GDP again going down and so on. So basically this kind of change point detection actually enables us to identify the regime changes, which is important also because it may help us to understand why such changes happened. If we can suppose I know that okay, the time series changed at point T1 and T2, then I may be interested to understand, so what are the events that happened in the world or in the country around these times that may have had a bearing on the time series, right? So that way it may help me to gain some insights about what are the driving factors behind this time series. So identification of such change points is another problem in which machine learning may help in or may be useful for various problems related to economic time series. Now so apart from this numerical time series, we may also come across non-numeric time series. So a non-numeric time series, for example, maybe it may be like a time series of say discrete values or binary values. So that is, instead of considering real numbers which can be plotted the way I was plotting here, I may also be looking for some time series of some attributes. Say for example, who at any given time, which is the most popular attribute or most popular value of some attribute of any item, and how that varies over time. Say for example, colors of cars. So in every month, I may be interested in measuring or what is the most popular color people have chosen for while buying cars. Like have blue cars been bought maximum, or is it white cars, or is it black cars, or red cars, or what? So and how this choice has been varying over months. That may be like one example. I'm not saying this is a very important or insightful problem, but this is one economic problem. Another problem might be that it may be simply a binary problem, that is predicting whether the sales of a particular item is its past value, it's the sales of that item till a particular point of time. Now you want to simply predict, are the sales of this thing going to go up or going to go down in the coming quarter? And so that's a simple binary classification, this is simply a binary time series. At every that is for every quarter, your time series simply measures whether whether the sales in that quarter is higher than the previous quarter or lower than the previous quarter. That's a simple binary time series. Then another is reviews. right? So suppose, so we know that this is in this era, like every agency or every service, in every personality, like every say political leader, or every like say business person, or every company like Amazon or Zomato or whatever, we give ratings to these. Now these ratings, different people have different ways of giving ratings. In case of a company like Zomato, whenever the people use their service, we may use their app to give them ratings out of five stars. If it is if we are talking about say something like a particular property or a particular hotel which is used by, which is advertised through agency like booking.com, there again the different reviewers or the different users give it reviews by giving 1 out of 10 stars. Then again, we know that for political personalities, there are different these opinion polls which which may ask that whether this particular president or that particular prime minister or that particular chief minister, are you satisfied with them or not? So accordingly, people give some ratings. So we this way we can get a time series of these reviews like this, and we may be interested in understanding how these like for any particular entity how their user reviews go like vary over time. So can we say that that is, can we identify certain agencies whose reviews are gradually falling off and is likely to lose patronship, or there are some agencies or some entities whose like which are becoming popular quite rapidly and things like that. So these are some examples of non-numeric time series. Now the problem with non-numeric time series is that most of the mathematical models which we develop for time series, so like for example the one comprising of the trend component, cyclical component, random component, effect of covariates, etc., that may not work directly in case of non-numeric time series. Why? Because the data is non-numeric, it is not expressible as real numbers. So for that we will need a different class of algorithms, we'll need a different class of models also. Another another thing which may be interested in case of non-numeric time series like this is that we may try to use a class of algorithms which are known as the sequential pattern mining algorithms. Now what are these sequential pattern mining algorithms? So one example of that we will see. So for that, let us focus on one particular problem which is dealt with. Earlier it used to be dealt with various large retail shops or say supermarkets. Nowadays they are dealt with these recommendation sites or these online retail sites such as say Amazon, Flipkart, or so nowadays there are so many sites for online sale or online grocery shopping, etc., etc. So for that, the particular problem which I am talking about here is called market basket analysis. So it is the question here is quite simple. Which sets of items does a customer buy together? Say for example, if so let us look at the transaction history of different customers who may have come to a particular grocery market, and so this database basically includes what all items different customers have bought together. So the first customer has bought bread, butter, milk and sugar together. Then another customer may have just bought eggs together, and similar, and so on and so forth. So these may give us an idea about typically when or what are the set of items or which any customer may like to buy together. Okay? So if that is, so what is the aim of understanding such sets of items? So first of all, I may improve the store layout. So if I suppose I know that whenever anyone buys a butter, or let's say whenever someone buys bread, it's also likely that they are going to buy butter. So in that case, one way of thinking is that I should place butters quite close to where I am placing the bread, so that after picking up the bread, they can easily pick up the butter also. The other line of thought is the exact opposite. If I know that bread and butter are likely to be bought together, then I may actually want to place them far apart from each other, so that because I know that after buying bread, the customer will go on searching for butter, and if the butter is placed far away from the bread, then I may expect that in the process of searching for the butter, the customer may see some other things and may be interested in buying them also. So that's another different way of thinking. So whatever it is, you like, if you know these sets of items which are bought together, that may help in this improved store layout. That is, you may design your retail market layout in such a way that which may either help the customers to quickly pick up whatever they are interested in, or it may help in boosting your sales by incentivizing or by nudging them to buy more things, the second case which I just mentioned. Now let us move from the offline domain. Let us move to the online domain for the same problem. So suppose like there is an online retail shop in which I am trying to that is in which a customer is trying to buy, let's say, grocery. So suppose a customer has ordered one particular item. Then what happens typically in a site like, say, Amazon, or like, say, Amazon Fresh or something like that, whenever we order something, what we see is that there are lots of recommendations. They say that people who bought these typically also bought those. We see such things being written. So what the site is basically doing is that it is recommending some new things to me, or some other products to me, based on my purchase history, based on what I have bought in the past. So it may be on the general public's history, or it may be on my own history also. So like basically, if it may happen that whenever people buy bread, they also follow it up by buying butter. But it may happen that in my case, whenever I buy bread, I follow it up by buying jam. So in that case, the engine may be tempted to suggest both butter as well as jam as recommendations for me once I have bought a bread, right? So so why is this important? This is extremely important for the recommendation for these sites like Amazon, for whom this recommendation is the ability to recommend the products is a very large part of their success. It's a very if it does a good job of recommending, its sales also are found to and its reviews are also found to improve by leaps and bounds. Right, so that is the why we need to do the market basket analysis in case of these online retail sites. Now, so let us try to pose it as a time series problem. So let us say that for a given person, I have the purchase history. I know that when this particular person purchased which item at which point of time. Okay, and then what I am trying to do is I am trying to forecast what's the next item that this person is going to purchase. Okay, so like for the data in this case may look like something like this. That is from the I will have the database of the past purchases of that person, the timestamp database of the past purchases of that person as well as the other persons. So that database, that database may look somewhat like this. So let us say that I have 6 users, and like there are these 12 say different days or different, let's say that these are different days. So it's like saying that on day T1, this user 1 bought an item A. I mean, they may buy more than one item also on the same day, but let us for simplicity, let us just assume that user 1 on day T1 has bought an item A. On day T2, he followed up by buying item B. On the third day, like nothing was bought. On day T4, user 1 bought item C, then item D, then item E. Then there was a break period where nothing was bought. Then A, then again nothing, then B, and then again C, etc. So again, for similarly for user 2, we see that like they are buying patterns and so on. So now, this is what a typical transaction history database may look like, and on the basis of this, I have to make predictions that on the 13th day, if the user 1 turns up, what is it that they may want to buy? Similarly, user 2, given that this is what they have bought so far, what is it that user 2 may buy after this, etc., etc. Okay. So now how to solve this problem? So if you look at this database, you may be able to form some kind of an idea. So suppose this is the past transaction history of user 1. Then can you suggest what is the next thing which the user 1 may buy on the 13th day? Any idea?
So it can be the most frequently bought things.
It may be, yes, it may be the most frequently bought thing, that is whatever user 1 buys most frequently. It's possible that you on 13th day also you will buy the same thing. Anything else?
D, as it comes after the user bought A, B, and C, and the
Exactly.
pattern loop cycle is it.
Yes, that's a very good observation. So see, like early here in the last 3 purchases of user 1 were A, B, and C. This same pattern has repeated earlier also, A, B, C, and in that case it was followed by D. So it's possible that the user will buy D. I'm not saying that this is necessarily true. The user may buy, as was just mentioned, a user may have a favorite item which they may buy after this. So that's also possible. But it's possible that the sequential effect is important here. That is, given that A, B, C has been bought, and it was followed by D last time. It's possible that this will be followed by D. Okay. So now, so based on this, we will learn an algorithm which enables us to identify these kinds of item sets which are bought in sequence by any user or by different users, and based on that we will try to make predictions about what that user may buy next. Okay, so that class of algorithms we will discuss in our next class on Thursday. Okay, so with that, let's end today's session. Thank you, everyone.
Thank you, sir.
Thank you, sir. Thanks.
Thank you. So yeah, thank you, everyone. So unfortunately today I have to rush for another meeting, so I won't be able to take any further questions now, but we'll continue this discussion in our next class on Thursday. Okay, and these notes are available in the folder. Thank you.